Today we're going to go over the Trustgrid architecture and a demo of the Trustgrid portal. Key to understanding Trustgrid is understanding our zero trust networking concepts. At its base level, Trustgrid supports connections from any device, any agent, any branch, and any cloud into a single virtual network overlay. With Trustgrid, the virtual network is the software-defined perimeter that can support segmentation for individual users or applications. Permissions are granted for application or users to communicate on the virtual network with integration to leading IDP solutions as well. Unauthorized users or applications are dark to all other resources on the network. Let's take a closer look at the Trustgrid network architecture. Here we have a fairly common Trustgrid deployment. On the left-hand side, we have a centralized application residing in a public cloud environment, connecting into the virtual network overlay by virtue of a gateway node cluster. On the right-hand side, we have a data set in a private data center connecting into the network by virtue of the edge node cluster. The data plane is established between the edge node cluster into the gateway cluster using TLS tunnels that originate from the edge nodes into the gateway cluster. This allows a lot of flexibility when deploying those edge nodes. They can be on the public internet or behind a firewall without a lot of firewall reconfiguration to be done. The data plane is point-to-point, in this case, a hub and spoke architecture that allows that network traffic to pass on dedicated encrypted tunnels that are unique to each Trustgrid customer. That data never passes through our multi-tenant control plane above that is the orchestration, portal, and API layers of the Trustgrid solution. Many of our customers prefer to have this point-to-point data transmission and rely on the multi-tenant solution simply for management and orchestration. Let's take a look at Trustgrid's edge compute technology. Trustgrid's edge compute features enable next-generation application architectures that deploy application services or components anywhere from the public cloud to private data centers to branch offices or on individual devices such as ATMs or MRI machines. Trustgrid supports deployment of Docker containers, applications, or scripts on these Trustgrid nodes that extend the functionality well beyond a network appliance into an application platform. Trustgrid provides full application lifecycle management features for these applications, including deployment across Trustgrid nodes, version updates, and secure execution. Our customers are leveraging these solutions to optimize their applications for low latency integrations to user and application traffic, to direct high bandwidth use cases into low cost of bandwidth data centers, and to leverage hybrid cloud architectures to cost optimize public cloud services. Trustgrid supports an open agent architecture for easy integration to application agents residing on Windows, Mac OS, Android, and iOS operating systems. Trustgrid currently supports both WireGuard and OpenVPN open source agents, as well as delivers a WebSocket-based API for easy integration to other deployed agents. This avoids the rip and replace conversations common in upselling SDP solutions to existing customers leveraging VPN clients on solutions deployed. These hardened server configurations force most of the security enforcement and configuration into the virtual network itself, which leaves these agents both flexible and minimal to access the virtual network. Our gateway clustering and high availability support means easy scalability into hundreds and thousands of concurrent users. A captive portal for network traffic ensures users connect at the network level into a dark net with access to no applications initially, must then redirect to the IDP of our customer's choice for user level authentication, then have an application-specific security policy deployed, which only then enables access to applications. When a user first connects into the Trustgrid network prior to IDP authentication, they can't even resolve the DNS names of the applications they will access eventually. Trustgrid supports advanced self-service device and agent registration and provisioning to make the process of global rollouts of these agents very easy. Let's talk about the Trustgrid control plane services. These services reside predominantly in Trustgrid's public cloud, multi-tenant, portal, and API infrastructure, and behind-the-scenes services that provide orchestration for the management of these nodes once deployed. Trustgrid's cloud portal will be demonstrated here in a second. And keep in mind when looking at the portal, every feature that is exposed in the portal is backed by an API call first. At Trustgrid, we develop the API initially and then build the portal after that. Most of our customers rely extensively on our management APIs for network management, as well as integration into the security services and reporting tools unique to their deployments. In our control plane services, Trustgrid relies on identity-based access control with integrations to leading IDP providers. Our virtual network overlay is centrally controlled from the cloud, including control of all routing tables on all Trustgrid endpoints on the network, which enable dynamic routing and easy integration into cloud routing tables such as Amazon. Trustgrid runs a PKI to ensure no pre-shared keys are used on any Trustgrid nodes in the network, and manages all of the certificate enrollment, revocation, and renewal processes automatically. The Trustgrid cloud monitoring infrastructure can be a complete replacement for existing monitoring tools or supplements those tool sets well. Trustgrid provides monitoring at the appliance level, including hardware resource consumption, at the network level, latency and availability, and at the application level, Trustgrid updates, patches, and so on. Trustgrid manages its own app repo for all updates to the Ubuntu operating system and our applications that are rolled out as a single update package with advanced failback and recovery features in the event of a bad update. As with many SD-WAN providers, Trustgrid's centralized configuration portal and API ensure that all configuration information is stored first in a database in the cloud and then pushed out to the node for application to the individual node or cluster. This eliminates version control hassles from the network management process. Trustgrid's customers, especially those with large numbers of nodes deployed, demand advanced remote management tools to quickly identify root causes of issues without escalation to expensive engineering resources. In the portal that we'll see in a minute, Trustgrid has deployed many advanced networking tool sets directly in the user interface so that lower-level network technicians can perform advanced troubleshooting and management features without engaging those more expensive resources. Our container registry for Docker containers is the master registry for all containers deployed on the Trustgrid network. These are those edge compute containers that our customers are uploading into the Trustgrid portal, defining management features, and then deploying out to those Trustgrid edge and gateway nodes wherever they may be installed. Finally, Trustgrid centralized reporting tools allow you to have the auditability and reporting to quickly identify any changes made, any problems encountered, and any other system information needed. As mentioned earlier, Trustgrid supports a variety of data plane endpoints. Our cloud nodes support the 4 major cloud vendors, Amazon, Azure, Google, and Oracle. Our hardware appliances are delivered on x86 architecture white box appliances used by many of the leading next-gen firewall providers today, are available at low price points, and are easily pre-configured and deployed on-premise in environments where IT staffing may be a challenge. Trustgrid supports both Hyper-V and vSphere virtual appliances for easy deployment in existing private data centers or private cloud environments. Trustgrid's SDP agents support WireGuard, OpenVPN, and via our WebSocket API, a variety of other Windows, Mac, iOS, and Android agents. Let's go take a look at the portal. Here we find ourselves, after authentication, at the Trustgrid homepage, the main dashboard. Let's take a quick tour. The charts you see here are completely customizable per customer and per user. This data can be customized to display any of the data you'll see in the portal today across a variety of chart types. We support up to 9 of these charts total, and we'll configure these as part of the implementation process with easy changes to be made afterwards. A Trustgrid search bar allows you to quickly identify the resources that you're attempting to access without having to drill down through pages of node names or other resource names. The Trustgrid nodes list are important resources to quickly see the complete listing of all the nodes deployed in your infrastructure. This is a quick glance of our node list, and we'll find more detail on our nodes page, which between this page and the clusters page represents the vast majority of configuration you'll be doing with the Trustgrid software-defined networking features. Here we see a listing of the Trustgrid nodes deployed in this network. A quick tour. Our checkboxes allow us to manage many of these devices simultaneously. You can quickly see the status of each of the Trustgrid nodes. A Trustgrid data plane, which is what this reflects, can be enabled or disabled with a click here to temporarily disable all communication across that tunnel. This is especially helpful in situations where there might be a security breach on one or the other end of the tunnel that we would like to quickly disable all communication to prevent spreading of that problem. The control plane is connected at all times, as indicated by the green circle here, which allows us to manage the node even if we've terminated data plane connectivity. Trustgrid naming schemas are important for our customers that are managing hundreds or thousands of nodes in an environment. You can quickly, using this search term, drill down to find the specific nodes that you're referencing. If you're using account codes, as many of our customers in multi-tenant deployments use, we can quickly drill down to the account code that we're looking for and find the customer that's affected or calling in. Trustgrid leverages flags to have a quick visual indicator for certain nodes that may need more attention than others, or maybe more highly used and would like to be quickly accessed in this list. These nodes are part of clusters, Trustgrid high availability clusters, which support automated failover in the event of an outage on one or the other device. Trustgrid supports an active standby model where one device passes traffic and fails over to the second. The device currently passing traffic is indicated with this icon. The version of the software run currently on these nodes is indicated here easily, and the public IP address it's reporting. And then for our power users, Trustgrid supports easy SSH tunneling through the control plane to the individual devices to access a restricted session on the Ubuntu operating system on the appliance directly. Our power users leverage advanced network troubleshooting and other tools in this session, and all access to this terminal is logged. If you were to perform a port scan on a Trustgrid node, you would not have any open ports on the node. This SSH session is listening on local host only and can only be accessed through the Trustgrid connection. Let's drill down into one of these nodes. This is the home page of a node view. Our breadcrumbs here allow you to see at a glance the current connectivity status of this node. The circle indicates the control plane is connected. That is, access to the Trustgrid management infrastructure in the cloud is active, and we're able to manage this node. A control plane that is disconnected prohibits remote management of this node. This icon indicates the data plane is connected, which means that this edge node is connected to one or more of the gateways deployed in the network that are exposing applications into the network. We have a variety of charts and graphs here to show the current real-time functionality of this node. Here we see hardware resource consumption, current VPN traffic volume, overall traffic volume, flows, connected peers, and TCP errors in the network. Currently, this device is configured with only a single network. However, Trustgrid supports a large number of concurrent network segments that can be used to isolate applications, traffic, and users, and support single tenant or multi-tenant data planes for each defined network. At the top of this page, we find the management tool sets. The terminal we saw previously, restarting of the service, rebooting of the appliance, an upgrade when available, and a refresh. We also can get more detailed information about the node, also see its control plane connectivity, control the status of the node, and view our custom tags. Trustgrid supports custom tagging of all nodes and clusters so that you can integrate the support data needed for this connection directly in the tools used for support. The public IP, the version information, the current profile, which is the configuration information, and our global unique node ID if needed for support. Trustgrid's network mapping feature here shows a very simple network architecture of a single set of edge nodes connecting into a single set of gateway nodes. We can click the icons here to determine the current connectivity status. The green line indicates a healthy connection from the edge node to the gateway node. Red would indicate a failure. By clicking it, we start mapping in real time the latency of this connection, which can quickly isolate any network performance problems. Because this node is part of a cluster, much of the management will be performed at the cluster level. At a glance, our cluster overview page shows us the domain it belongs to, which is a method of applying security and configuration policies to groups of nodes, its cluster configuration, whether it's an automatic or manual failback, and the current status of the cluster. In this case, this is a 2-node cluster. We can see quickly which one of the members is configured as the master. This is the original configuration, which is the current master passing traffic, and the status of the cluster. In this case, the healthy indicator specifies that the heartbeat traffic moving between the 2 nodes is healthy. We can apply custom tags at this level as well. All changes made in the Trustgrid portal are audited and logged. Our network configuration can occur at the cluster level, of course, only for the cluster IP address here. Trustgrid typically uses a VIP or virtual IP address for which one of the 2 devices will ARP to determine the master or secondary traffic. Our services, connectors, and VPN configuration all exist, and our edge compute configuration can be found here. Let's go back to the node configuration where we can see some more detail. The Trustgrid network interfaces can be managed from this page. This device is a 2-interface deployment where we can currently see configured for static IP address with a private IP address and DNS servers. Trustgrid does depend on DNS services to connect back into the control plane, but has a robust set of failback features in the event these DNS services are unavailable. Interface routes can be handled here, and any change to a WAN connection should always be done carefully. Trustgrid offers a try feature that will apply the new configuration and automatically revert if that configuration does not support reconnection to the control plane within a fixed amount of time. Here, we find some of the first troubleshooting tools that we've talked about previously. I can quickly, from this edge interface, treat the host as a bastion host deployed within a remote environment. I can ping a specified host in that remote environment from this host, even using the cluster VIP to overcome the fact that there may be firewall rules in place that prevent communication from any IP that is not this cluster VIP, from which all traffic should resolve in normal operations. I can also sniff the interface traffic quickly if I want to confirm the traffic is passing on here. I can specify the interface filters and any other traffic filters that will be common to anyone using TCP dump in an Ubuntu environment. Here we can quickly see the traffic that is passing on the network. You'll note this only captures header information. We do not show payload information to protect the security and privacy of the data plane connections. Our VPN configuration is where most of the virtual network overlay is configured. So the virtual network is configured as part of the domain configuration under this demo domain, the network of space, and so on. We can configure port forwarding and routing tables unique to this environment, as well as individual inside and outside NATs for this node on this page. We have additional troubleshooting tools here that you might find familiar from the last tool, as well as troubleshooting VPN traffic and viewing the virtual network translation table, which can be especially helpful when NATing entire network spaces. Our layer 4 proxy features and services enable Trustgrid to operate not at a layer 3 tunneling layer, but as a reverse proxy for traffic where appropriate. This does disable some advanced features like automated disaster recovery, failover between multiple sites, but may be a quick and easy way to get traffic from a remote network into another network or vice versa. All events and alerts are logged here and can easily be integrated into the third-party solutions of your choice, as we'll see in a minute. NetFlow logs represent an important troubleshooting capability when trying to identify performance of the network over time. Trustgrid supports advanced search features that allow you to specify the exact date and time, as well as source and destination nodes, and any other filters you may want to apply, and identify the traffic quickly. Trustgrid stores all NetFlow information for 30 days and supports integration to the SIM product of your choice via our API or other integration methods, as well as an export to S3 buckets. All changes made to this node will be displayed easily here, and the audits for this node will display all activity from the node. As we can see, my current user invoked several node terminal commands, has sniffed interface traffic, and just days ago performed a node update. These nodes support SNMP version 3, individual maintenance windows, cluster information, especially the support or the port that is used, and we can see the other cluster members at a glance. Gateway nodes accept incoming connections and are typically located adjacent to applications that are shared into the network. In this case, we can see that this device is not a gateway and cannot be configured as one due to limitations enforced at the Trustgrid level. Finally, our alerts on this individual node can be configured across a number of different metrics: hardware resource consumption, network latency between specific nodes, and bandwidth utilization in or out. These alerts can be configured globally in terms of where this information is going once configured. Let's take a look at the Operations tab, which will help us configure those settings. This presents a global view of all Trustgrid nodes, any events that may have occurred in the network, including node restarts and updates, all flow logs globally, which can easily be accessed or exported to S3, all changes made to the environment globally, any authentication, the user, the source IP, the changes made within these individual nodes, and any updates applied at the operating system level, including the previous version and the new version. The alert filters are an important feature set for us to call out here. These alert filters allow us to gather information from the Trustgrid portal and integrate that information directly into the tools that you're using every day. This prohibits you from having to maintain an active connection in the portal or to add yet another tab to your browsers that's open all the time. So here we can specify the alert name and the outcome of that alert. So we can take any type of alert for any one of the nodes and quickly route that information into the Slack channel of your choice, escalate via PagerDuty to OpsGenie or Microsoft Teams. Trustgrid relies on this heavily in the management of the infrastructure and the creation of a number of specific channels that are constantly streaming alerts and data into those channels that make it easy to see the performance of the network as a whole. That wraps up our brief tour of the Trustgrid portal and an overview of the Trustgrid technology. Thank you.